We're going to be going over Angular 17. I titled this beginner friendly, veteran ready because of the three, I call them the three godfathers of the front end frameworks. So Angular, React, and Vue are like the biggest ones. There's a lot of front end frameworks. I have been using Angular since AngularJS, so 6 or 7 years. I enjoy it, but I'm a contractor by trade, so I use all technologies. I have no brand loyalty whatsoever. So that way, you know, people who were like, I prefer React or Vue, and I'm like, tell me, because I really want to just know what you don't like and what you do, and I want to pick your brain on how we can improve it. That being said, Angular has been one of those slow and steady wins of the race. They have been around a long time. They're backed by Google. But front-end frameworks are very Wild West, and Angular has built a foundation for a lot of enterprise software to being very stable, and that's kind of how they pride themselves. The downside to that is that means they are slow to change because they have to make sure they're backwards compatible, and they also have to make sure that they are functioning in a way, because they're a full framework, that all pieces work well together all the time. React, I have always enjoyed that they're chaos because they're not scared of change at all. Like even if it's like breaking changes, they're just like, let's do it. 17 was like, you know what, let's try that, and they did. And 17 has taken a lot of the good features that work well in React, Vue, and other technologies and brought them in. And they didn't just slowly bring them in. They were like, now it's this. They flipped a switch, and it's a hard switch. We'll start with just their branding. They decided just to take a lot of community feedback, and they were like, boom, we'll just make it like more colorful and have our documentation look better. And from here on out, I feel that Angular is going to start to try to make more significant changes more often and allow the community to kind of tell them no, versus having the fear of big companies say, we're not going to use that. Because in all honesty, that's really what has driven a lot of their updates in the past. So, there are a lot. We're only going to go over probably 3 or 4 big ones, and we'll mention the other ones. But first, before we go into any features, they spent 2 years on their new documentation website, and it is phenomenal. The biggest complaint I've always had with documentation sites is that it's split into 3 categories. Your hardcore documentation that describes a very specific feature. You have your examples, which are usually like the minimal case. Like most people are going to outgrow that within a Hello World application. And then finally, if you want an actual real world code example, you have to go to like StackBlitz or Stack Overflow, or you have to Google it, and they're not all in one place. Angular.dev, they put all that in one, and it looks really, really good. I gave it to someone that I work with that's a junior dev at one of the contracts I'm at, and they were able to pick up and learn very quickly. I have an outstanding subscription to a lot of learning modules that I just give free to a lot of people. I only pay for 1 license, but I like to just give it to people. So that way people can learn. And this website was one of those that I think I would probably start with giving people who don't know much about Angular this site first and see, because they have a playground now that allows you to like, I don't know what a template is, okay? I can instantly go there, read about it, get an example, and play with it live. And I don't have to download code. I don't have to waste my time trying to figure out how to get it to run or work. I can instantly just see one small bit and work with it, so that way it's modularized, and that really helps with the learning experience. So highly check this out if you haven't been to their documentation website, but it is still very new, so if you find stuff that's either missing or examples, definitely drop a line on one of their GitHub issues, because they're looking for feedback. Where do we start? So I have went to a lot of conferences in the past year, and a lot of them do talk about different types of Angular. So much so that I have found it hard to kind of keep up with it, and I've been working in this framework for a really long time. So what I decided to do with this talk is something different. I'm only going to verbally talk about the old, so everything before 17. And I'm going to visually show the new features. And I do that because people who are veterans or experienced with Angular, my hope is that they'll already know how to connect those 2 pieces. The people who are unfamiliar or new to coding, we won't distract them with all of the stuff that they may not even need right now. So the visual we'll be able to share for both beginner and veteran, but then I'll verbally talk about the differences. And if you have questions and you're new, then we can talk about that. But I don't want to bog people down with the boilerplate semantics for a lot of stuff. So that being said, the control flow is the biggest feature that I have really enjoyed working on. before we had all of our ng directives, and one of the lead developers, I love this whenever they talked about this, but one of the lead developers of Angular said that he has always hated them, and he's the one that created them. He has to look them up, and that's saying something about your technology. Is if one of your core architects of that technology doesn't like it and doesn't remember how to use it, there's a problem. And so control flow syntax starts to write code like this, to where this is inside a template. So inside your HTML, we can now put stuff like this. I have two examples here, but before we would have a star ngIf, and a lot of people would be like, well, how does this work? How do I know what's toggled on, what's toggled off? What if I want to put an if in multiple places? Control flow syntax has made it to where how humans read is how we should code, and that should be fundamental in almost all technologies. I put a 4 down there because that's actually the example that he gave, was no one knows how to use the 4 directive before 17. Like, I'll be honest with you, I look it up all the time. I have like a project that I know has everything in it, and if I ever forget something, I just open that project and go, it's here, and like I file it away. And now I don't have to do that. This is just how I would write code anyway, and I've been writing this since I went to school a long time ago. So control flow syntax, great stuff, good stuff. We'll show examples of all the real code here in a second. The next one is probably, this is the #1 rated on their GitHub issues, and this is why a lot of developers do not adopt Angular. In fact, the React community has pretty much said that your modules are the reason why your framework is bad. And I think Google knew that. They just didn't know how to get rid of it because it was so tightly coupled to their technology. All you need to know about modules is that they were a way to group your components. They started off as just having one. So imagine a book with a whole bunch of chapters of components. It ultimately realized they couldn't scale that, so they did feature modules. They did lazy loaded modules. They had ways of having eager versus your lazy and all these different concepts, but it's a very advanced concept to where adoption rate was very low because it's such a confusing thing to do. So they didn't kill it per se, but it's not default anymore. So standalones, and I don't want to say components because you can do pipes and you can do directives and things like that, but standalone is just a self-contained piece of code. I liked the quote that they have on here is that silo your code like you would everything else. So your standalones have all of your imports built in. You can inject your services directly in there. They can talk to each other, so there's no reason to if I have component A, B, and C, and they're siblings, and then W, X, and Y are different, there's no organizing them anymore. They're just components, and you should just be able to work with them with ease without having to understand how the relationships work. Dependency injection is the only one that I've had difficulties on. It's actually so simple that I had a problem with it, and that's because I was so used to modules. Before I had to understand where things were and how they were understood. But now when it comes to services specifically, we'll show an example of this, but you can inject services, with the exception of if you're making a component library, anywhere you need them very simply by just adding a reference somewhere in your main TS. So these are advanced, and I'm only putting bullet points because I'm just going to talk about the subjects, and then we'll kind of go into the code example that I wrote. The last one is reactivity. Angular's concept of the push architecture, and for those who are unfamiliar with that, push architecture is concept of your service layer has data, and I want to push that out to my components without any care in the world of who's listening. Angular has always been very difficult with that because you have to understand how they communicate with each other, and that was done with observables. I have always loved React's way of doing state and the push architecture, but Angular has adopted the concept of we're going to give you the tools, but you have to build that solution. The problem with that is you will never be smarter than the tools that you use. So you have to understand when you create, for example, if I want to just simply push and update a name, right? Everyone's created a user profile or something, and you want to push that out to your components, your dumb components. Well, they have to subscribe to it. You have to know when to unsubscribe to it when it's destroyed, or else you have memory leaks. And you have to manage all those things yourself. There are tools out there that you can download, but again, they're not baked into Angular. They're pushed off and offloaded onto the users. And you will never be smarter than that. So Signals replace that, and you can still use observables, but I'm at the full stop where I'm starting to convert everything over to signals, purely because I have reduced my code for boilerplate code between observables to signals by at least 75%. And the second thing is that I no longer have to worry about subscribing and unsubscribing and having those memory leaks. Those are all baked in because since they're part of the framework, they already know all of the ways that your lifestyle hooks will work. We're going to show a lot of examples of how these have improved, but state management has pretty much been, you have to figure out your own way. And I have modeled a lot of my stuff from React's community and pulled it into Angular, but with Signals, that sort of transition between the user's responsibility and the framework's responsibility is becoming smaller and smaller. And I think that makes it a lot easier for people to adopt this newer version because they now can just trust that the framework is going to do those things and not have to figure out what is my involvement in this? What do I have to do? Because normally when you do that, those are called unknown unknowns. And you will not know you had a memory leak until someone lets you know because you wouldn't have had it. You wouldn't have purposely put one in there. So we'll show an example of that. But I wanted to mention, these are some notable changes. When I said that Angular 17 was big, there's a lot of huge stuff. These are not in any priority whatsoever. They're just some of the bigger items that are on there. Deferred views, we won't get to, but those are great for speed improvements. Those are things like don't render things onto my screen until it gets into the viewport. So let's say you have 50 cards that you had to load, but only 10 of them fit on your screen. There's no reason to load the extra dead weight onto the screen. That's bandwidth, that's also speed. You can defer your views in a lot of different ways. Lifestyle hooks, there's a couple new ones. Material 3, that is only right now in a release candidate, so it's not out yet, but it's pretty exciting stuff if you follow the material concept at all. Input transformers, this is one of those features that I think every React person was looking at, especially the community that talks about two-way bindings and just transforming data between parent and children. I love this feature. I really wanted to put it inside this project, but I didn't. But input transformers are really, really cool. And the last one, and this is kind of an offshoot, but Angular Universal is now gone. And I don't mean like, don't use it. I'm like, they're not going to support it anymore. Angular Universal was a server-side rendered version of Angular. Even though it had Angular attached to it, it was a very separate piece of technology and very, very complex. Angular 17 now has server-side rendering baked in. I can tell you I've used it. It is really awesome, but the people who use Universal have not adopted it because it is no longer a separate piece of technology. So you're asking people to completely rebuild their applications in a different technology. So that adoption rate is going to be very, very slow. But the statistics that are out for it right now are very promising. But that one I'm still kind of holding out on. I've made a few trial programs, but it's pretty exciting stuff, the fact that that's already just going to be built in. Yeah?
Are you building analog JS? It's like a
not yet, but they did pitch that as far as ngconf is coming. They want to have an entire separate section for that, which will be pretty exciting. That being said, we're going to go ahead and show a demo. I do have a code example, but before we show that, let me pull up the project real quick. So we're going to load. First thing you do is when you load inside this application, there's a loading indicator. I'm going to demo this before I show the code, so that way you can kind of see how the pieces work together. After we've loaded, we have a simple login screen. Do not make fun. It's a login screen that shows all my users, and this is for demo purposes. Don't create a login screen that does this. We're going to go ahead and do Luke Skywalker. Select him. We're going to go ahead and log in. When you log in, you're ported over, and it loads Luke's profile. Shows all of his data. If we go and hit back, let's go ahead into Obi-Wan. OG Obi-Wan, not this new Disney stuff. So OG Obi-Wan, now his profile is loaded. So what is this doing in the background? I'm going to take it off full screen. It's pretty small, but as you can see up at the top, this is just, the URL is just /profile, but we've loaded in two different people. I'm doing this because I have a global state that I'm loading in and I'm throwing between data. There's no parameters up at the top that are passing in IDs. I'm not passing in any inputs between components. These are two separate components. They're sharing state. And I was able to do this very quickly. In fact, the loading indicator that we have here is also another thing, right? I was able to use a simple control flow syntax for if I want it, if it's loading, show the loading indicator, and if it's not loading, then show the actual login screen. So how is this working? Let's go ahead and see that code. And I think I blew it up enough, but if people in the audience can let me know. Is that a good size for everyone? Yeah? Cool. The first thing I want to mention is that I took a concept from another framework and I created my own observable version of a state system. And it was very, very quick, very good, but I wanted to convert it to signals. And when I said I had a 75% minimum code reduction, this class at the bottom tops out at with a bunch of comments, which, by the way, for the people that download the project, I put JS docs and everything, so feel free to go in there and read about stuff. But even with all those comments, I'm still at a 56 lines. What that means is this is a base state class. What this is any service that I want to incorporate a simple state management, very simple, I can just extend this, feed it in an object what my state is going to be, and I already have some basic setters and getters. React is very used to having stores, so if you're familiar with that, that concept is very similar here. But this is my boilerplate code. So as you saw earlier, whenever I log in, I'm able to click a user, and then I redirect the user to their profile, and it loads that person's profile. So I have a service. In that service, I extend my base state, and then I also pass it in what my state object is going to be. So that's what I have down here at the bottom. Now, this particular state, I only have one, so technically it's a global state. But what did I do here? All I simply did was I extended, it's just a simple service, I extended my helper class, and then I passed it in an object of what I expect the state to be. The important thing to understand here first is that I want to make sure that my service is like my brain, and all of my components are dumb. And the reason why you want to do that is if you can separate your concerns and decouple as many of your components as possible. I can tell you writing code is going to be a lot faster, understanding it even better for reading. But anytime you go to update for that push architecture, your components, it will be lightning fast. One of the things on here that you'll notice is when I have my state and between my two components, how are they letting each other know? Well, they don't care about each other. In fact, the login screen has no idea the profile screen even exists, or even if the profile screen has sibling components or children. That's the beauty of having a better state management system and also having a push architecture. So we're going to bounce between these, but I wanted to show that by extending that, simply having my state interface in here, now I have state within this service. But how do we interact with it? So our login screen, let's go to that real quick. This is a standalone component. We're going to go to the template real fast. Collapse a few things. First thing you'll notice here is we have the control flow syntax I mentioned earlier. I simply have an if and an else, and I say if my state is loading, which we'll show that here in a second, show my spinner, else show my form. And there's a lot better ways of doing this. This is just the most simple way if I'm going to have just a simple loader. There's those deferred views and things like that I'd mentioned before. There's actually loading states. So if you have loading, you can put custom loading logic in there. But I was able to just simply toggle two different things on here by simply doing an if and an else for my control flow syntax versus having an ngIf on one div and an ngIf, inverse ngIf on another, and then understanding how those are going to toggle back and forth. But how does that state inside this template, how does that work? Well, scroll down here. Inside my constructor, I have injected my service. Inside here, I have my state. Now, you can have a slice of state if you want to. I went ahead, for this example, I have a reference to my entire state. But I made it read-only. Why did I make that read-only? I did that because, again, I want my components to be as dumb as possible. So I don't want to mutate anything. Very important not to do that. But more specifically, when it comes to a signal, Observables, I would have had a copy of my observable. Inside my template, I would have had to have subscribed with that. Most people are familiar with the async pipe. Under the hood, what that is doing is that you are telling this component to take that piece of state, subscribe to it, and listen to it. Then, whenever this component is dead, go ahead and recycle it. The concept of an async component in a template is very well done. Unfortunately, inside the class itself for this component, you would have to have subscribed to it manually. And then you were expected to unsubscribe from it. There are a lot of different ways you can do that. And I won't get into all those examples, but the problem is that by forcing the user to be able to control the when and how of subscriptions, will always introduce some sort of memory leak in time. Whether you do it on a small scale like this or in a large scale application, it does happen. At minimum, if you don't have those sorts of things, you have issues with your code where it starts to explode, right? You have all of this boilerplate code to manage subscriptions. With the way that I have engineered this here, and it's very simple because this is exactly how signals were designed, I have a reference to this and now it's immutable. And so this class is simply just listening for any changes. Now, one of the things that a lot of people are saying is, I already have all these observables, do I switch them over? You can, and I would encourage that. But I work in an application right now where we have to kind of do it in a phased rollout, right? So we want to go ahead and convert things to signals, get some of the benefits of them, but not necessarily convert them one-to-one. So I have an example of that. First thing I want to show is this concept right here. I have all of my lists of people. But if I start typing in A, C, I will start to filter the items inside that list based on whatever I type. Now, how is it doing that? Well, the first thing we want to see, down here we have another control flow syntax. We have that for loop. And you'll notice that inside this for loop, I have a signal. It's called filtered people. It takes those, iterates through them just like every other for loop, and builds all my different options that you saw on there. A traditional observable, these are the caveats. A traditional observable, when you subscribe to something, depending on how you set it up, it will listen for those changes and it will pull what's in there. A signal automatically subscribes when you create it. So by default, the biggest, I wouldn't say issue, but the biggest complexity, which is very small, is understanding that a signal is self-contained, it automatically subscribes, and if you do not give it an initial value, you will get an undefined returned. That's a very important concept because I had mentioned about converting your original observables. If you do it by scratch and you rewrite the observable to now be a signal, you can give it what you want the default to be. If you don't, and I'll show you an example here, this filtered people is based off of a very common, I don't think I can minimize those. We have a control, so that's that input right here, is this person control. And on that person control, we are typing in data. Well, we want this value change, and we say, when this value change, do something. And we'll get to that in a second. Well, this actually returns back, so this is an Angular form, and it returns back a observable, but I want to use signals. So in that phased rollout that I was talking about, one of the ways that I have done that is that there is a RxJS helper function called toSignal. What this will do is you can pass it in an observable, an existing one, and it will return back a signal. But on the right-hand side, I have an initial value. And that's really important because I had mentioned that signals subscribe right away. And so I want to make sure that it's not returning back an undefined object. That way it makes my components, or my template, excuse me, a lot easier to manage. Now I don't have to say if this is, I don't have to do a null coalescing operator or check to see if something's awry. I can just simply know that when this signal was created and it's initially subscribed, it has a base value. I didn't create this function, and all I have simply done is added a observable that exists. And if your application already has some, you can simply just plug one in there, and now you have a signal for it. But it's not a work all solution. So what I'm trying to demonstrate here is that, don't know why I'm looking on that screen when I have my computer in front of me. One of the ways to edit my state, and I'm jumping all around here so I can build a full solution. side here. We have our filtered people signal here. And this is a state that's only inside this component. Up at the top here, we have a state that is our global state that is shared with throughout the rest of our application. But they're both created differently. The global state was created as a pure signal, and I'm managing that state within the service. Whereas this filtered people, this is an observable that was converted to a signal, and that signal was then managed only within that component. The differentiating between these two things is that both of them still use the same technology, both of them still use state, but the complexity for them is no different. So I can go in one place versus the other, and they both act and feel the same way. That adoption rate is a lot easier because when you go from different components to different projects, unlike observables, the signals will only work in one way. And I say that, there's ways to change any piece of code, but for the most part, they work the same way. My experience has shown that observables have been very difficult to have a centralized way of using them. So before we go too far into that, I do want to mention that when you are editing state, that's one of the things that people always ask me is, if you're not allowing me to mutate my state or change it, how am I going to be doing that? Not ever in your components if you can help it. And I say that because if you have everything in one single source of truth, for example, my service, and I need to make a change, I need to do maintenance, I need to do anything, add a new feature, it's really easy to know where it is. But there's a lot of, I guess I should say, advanced topics with how that works as far as tree shaking and the optimizations under the hood. We're not going to get into that. But the more you get into this, especially on that angular.dev site, you can get further in and it will tell you how it's optimizing under the hood. So I think we've kind of covered the login screen, but how are we updating from the login screen to the profile screen when we do that? So we're going to simply kind of cut through this pretty quick so that way we can kind of see how they interact with each other. Oh, I'm in the service, that's the reason why. Whenever I submit that form, I just simply call it onSubmit. And the two pieces of code here is that I set the active person inside my service, and then I route the user to the proper route, right? So our profile. But what am I doing here? So inside the service, all I'm simply doing is I'm passing in a person name. I'm doing a bunch more stuff behind, there's other functions and things, but in essence, my service that I'm on here, so the Star Wars API service, sets that state, and it doesn't really care what it does after that. It says set that state, and I'm using this right here. It's the helper function on that base class. I send it in a partial class of my two new objects that I want to update, and that's it. My state doesn't, or my service doesn't care who's listening. The login user doesn't care who's listening or what's going to happen. It's simply saying, I know I have a job. This is what I need to do. Now, if we go over to the profile, the login screen was a lot more advanced, but our profile, we're going to close out of a lot of this. Also standalone component, and this is the entirety of that profile screen. There's nothing inside this code right here. It's like, I have a back button, and I could tell you I could honestly have removed that as well, but I put that in there on purpose just so that way you could physically see how I'm clearing the state, so to speak, or also changing it from another application. But there's also ways of removing that as well. This class now is just a very dumb class for a profile, and it's really just a card. So if we go back and look at what that is, I'm going to click Akbar, and I'm going to look at him. So it's a card. We got an image. We got some fields over there on the right. And we have a back button, center aligned. We go back over here to the code. As far as the actual code goes, we have very limited. We have the same concept where we have injected our service. We have a reference to the same state. We have a full. We didn't get a slice. We got the full on there right there. Go behind and look at the template. And this is where all the magic happens. I'm going to minimize a few of this. First off, down here, we have the same thing we saw earlier, where we have our state, and we reference it right here, and so this is what I have inside my image, right? This right here, unlike the other piece, this is a piece of our state. And we know, and this has our URL that I built, and if you look at the code later, you can see how I do some string manipulation to get this image URL. But inside, we noticed that we had his peripheral or his profile preferences inside there. I could have broken his profile out. I was lazy for this application. I went ahead and just referenced a single object, a person object. So I did have to check to make sure that it was null, so that way I don't have any issues if for some reason it was past null. But all I simply did was reference this state, the person object, and then each one of these different details and for this particular class that I have. And that's the entirety for this class. It seems really strange because traditionally I should have passed in, if you were following Angular's concept before 17, I should have passed in something via an input. Or I should have said, whenever I logged in or when this profile first loaded, either inside my constructor or my ng-on-init, or any of the other lifestyle hooks, go ahead and ask the server. That's the pull method. I want to ask the server to see what that data is. So I have removed all of that code. It's also much more reactive, so that way, and I will show you this, is that this data was being updated from another class. But what happens if I go up here to log in on the URL and I go to profile directly and I hit enter? There's nothing here because the state's been cleared. Nothing's updated it. The important part, the reason why I wanted to show you that is that traditionally, if you were to go to any component and you were to use the pull method, there's a lot of overhead. And some people would argue, well, that's the reason why I have everything on the ng-on-init, so that way I'm not dependent on other things. But that's not reactive, right? What I'm doing here is I'm saying one component is just doing one job and another component is doing another. When you change your concept here to a push architecture using a lot of the signals that you have here, you get a lot of reduction in code. But one of the best aspects of it is that this dummy component is so easy to use and to also grow. Mutation is always difficult to track online because one very important concept to note here is that if you're inside a profile and you want to make a change, like update your password or your name or things, traditionally you would do that in here, and then you would ask another component to do the work. Offloading that couples your components together. And the one thing you always want to do is try to reduce the coupling at all cost and have as much of your complexity inside your service so that way you can reuse it. So there's a lot going on here. This project, I will say, is very, very tiny. I have a lot more notes than probably code in here. I recommend downloading it. But we've highlighted a lot of the basic concepts of it, but states, the control flow syntax, we're not really subscribing. You've never seen anything on here in this project where I subscribe using async pipe or manually. I'm not having to unsubscribe to anything. I don't care about how these are being destroyed. Everything's all managed within the framework in itself. And I was able to just spin this up. I do have a helper class that I wrote that's not built in, but you don't even have to have those 3 functions that I did. I just did that so I wouldn't have to rewrite them again. So, but everything else was all built into the framework, minus the Angular material library that I pulled in because I wanted it to look pretty. But other than that, I went over a lot of stuff and I've talked a lot. I'm going to go ahead and stop there for now and kind of leave it open for any questions.